What do you think is more important, to protect the rights of Americans to own guns or to control gun ownership? When asked this question, 46% of all Americans said protecting the right to own guns is more important. The Pew Research Center surveyed 1,267 randomly selected Americans with at least a bachelor's degree and found that 559 believe that protecting the right to own guns is more important. Does this result suggest that the proportion of Americans with at least a bachelor's degree feel differently than the general American population when it comes to gun control? Use an alpha equal to 0.05 or 5%. So in order for us to run this hypothesis test, we need to first and foremost define our hypotheses. So in order to do that, we have, I'll write them up here, our null and alternative hypotheses. Okay, we were told that 46% of Americans said that protecting the right to own guns is more important. So the null hypothesis is that the population proportion, is equal to 0.46. And because of that, we want to determine if the proportion of Americans with at least a bachelor's degree feel differently. So because of that, we still have a population proportion, and we have a value of 0.46 from the null hypothesis. So then our alternative hypothesis then, since we want to feel differently, is that this is not equal to 0.46. Okay? And based upon this now, we need to describe that sampling distribution of the sample proportion. So the mean of the sample proportion, let's just be the sample size. Excuse me, the mean of the sampling proportion is not that yet. Mean of the sampling proportion is just our value for the population proportion, so 0.46, while the standard deviation of the population proportion, of the sample proportion, is the square root of p times 1 minus p divided by n. So this would be square root of 0.46 times 0.54, and we want to divide that by a sample size of 1,267. Okay, and when we throw that into a calculator, we should get an answer of about 0.014. So I'll write that down here. 0.014. Okay. And based upon that, we could then find our z statistic first in order for us to run this hypothesis test. So let me write that down here. This takes the value of the sample proportion minus the null hypothesis population proportion divided by the standard deviation. So our sample proportion, which I did not calculate yet, let me do that up here. This is 559 out of 1,267. Putting this onto a calculator, we get a value of about 0.4412. So our statistic then would be 0.4412 minus 0.46 divided by 0.014. If we do this out, we get ourselves a value of about negative 1.34. So a picture of this, if our mean is 0.46 right here, our sample proportion then will be about, let's say here-ish. But we want the this probability of it being not equal to 0.46. So based upon that, we also need to look at the value on this right side as well. So one on the left is supposed to be the negative version, the one on the right is supposed to be the positive, and we want the area in between, within these two tails. Is what this refers to. And we need to find a p-value. Now I have this template that would assist in us finding that being this. So we need our sample size of 1,267, number of successes as 559. We want the test population proportion to be 46%, significance level of 5%, and we want a not equal test proportion, or a true proportion. Doing so gives us the test statistic that we found of negative 1.34, and gives us a p-value right here as 0.1794. So let me put that on here. So this is 0.1794. 0.1794. And we can even see down here on the bottom it gave us our assumptions to determine if we have the normality check. Both of these are above 15, right? 583 and 684. So we have an approximately normal shape here. So our assumptions would pass. So approximately normal, and our assumptions pass. And I just realized I should not put that down there since I need enough space to write the conclusion. I put it up here. So this is approximately normal. So it passes. And we need our conclusion for this test, since, we just ran a lovely hypothesis test. So let me expand this out and write down here. Okay. At the 5% level of significance, which is what we found, at the 5% level of significance, our p-value here is 0.1794, which is indeed greater than 5%. So at the 5% level of significance, we fail to reject the null hypothesis in favor of the alternative where the proportion of Americans who say that protecting the right to own guns is more important. So at the 5% level of significance, we fail to reject the null hypothesis in favor of the alternative, where the proportion of Americans who say that protecting the right to own guns is more important is greater than 0.46 or 46%. I know that's a very long-ish conclusion for that, but that's specifically though what we had found based upon our p-value.